Hello, everyone. So, welcome to Monday. I hope you had a great weekend, and I hope you understood scatter plots because we are going to be using them again today and looking at a calculation that is needed in order to help determine which line that you could possibly draw through the data actually is the line of best fit that we talked about on Friday. So I hope you've downloaded your notes that I posted for you in the assignment because those are what I'm going to be using here to talk to you through this. All right, so here on your notes, you've got some data over here on the left, and you've got two lines that are possible lines of best fit. So let's first start by graphing the data. So the first thing I did was draw the two axes. You want to make sure that your increments on each axis are equal. And so we're just going to graph our data. So 2, 6, 1, 2, 1, 2, 3, 4, 5, 6 is up here. 4, 3 is there. 6, 7 is there. And 8, 5 is there. Now, you could look at this and go, Mrs. Dyer, there's no correlation there. And I would have to kind of agree with you. But even with data that looks like this, we still are asked to see if there's a line of best fit. And so what I gave you here is two different lines of best fit. I gave you this one right here, and I gave you this one right here. So what we're going to do is we're going to graph those lines, and then we're going to do a special calculation from them. So where did this start with the graphing? Well, you always start with your y-intercept. In the orange line, the y-intercept is 3. So we would put a dot right there. Then you look at your slope. Our slope is 1/2. So the rise is 1, the run is 2. So we go up 1 over 2, up 1 over 2, and we could draw a line of best fit through those points and on through the rest of our data that looks like this. Perfect. Well, now you do it with the pink one. Pause the video, draw it yourself, and then come back and make sure you did it right. So your pink line should look like what I have on the screen right now. If it does, great. If not, take some time and figure out where your mistake was. Sorry for the beep, and that's my oven going off. So now that we have two possible lines of best fit, we have to calculate what is called the squared residuals. What this is this is a measurement that tells us how far away from the line is our true data points. And when you calculate the squared residual for each line, the one with the lowest value is the line of best fit. So the way we're going to do this is we are going to count, let me use orange. For the orange line, how many spaces or lines do I have to cross to get from my data point to the line? So as you can see, the distance here is 2, right? It took 2. I'm just failing, guys. It's a rough night here for me tonight. I'm sorry. It took me 2 lines to get from my data point to the line, or from the line to the data point, I guess is the better way to say that. So we would put 2 squared. Now we've got to add this to each of the other data points. So let's look at this one next. Now, to get from the line to the data point, I had to go down. So therefore, this is a negative distance. So this would be a negative, and it went 2 spaces, and then we have to square it. Well, now let's look at this point over here. To get from the line to the data point, I went up. So this is a positive. It's a positive 1 that we have to square. We add it to this last one down here, which again, to get from the line to the data point, we had to go down. We went down 2 spaces, so this is a negative 2 squared. Now, if I add this all up, it's going to be a 4 plus 4 plus 1 plus 4, which equals 13. All right, well, that's a good start. Well, now let's see if we can go and do the pink line and see what the squared residuals are for that. Well, we start with this first one, and to get from the line to the data point, we have to go up, so it's positive, and that's a positive 3 squared, because we went 1, 2, 3. Okay. The next data point, from the line to the data point, we had to go down. So this is going to be a negative 1 squared. Plus, for the next one, we did have to go up. We had to go up a positive 2. So that's a 2. I don't know why I put parentheses around it. You don't have to. Only around the negative. And then for this last one, we had to go down, so it's a negative 1 squared. So now when I add that all up, it's going to be 9 plus 1 plus 4 plus 1, and this is going to give us a squared residual of 15. So therefore, by seeing this, we see that the orange line had the lower squared residual. Therefore, the orange line right here is the line of best fit. All right. So if that makes sense to you and you're ready to rock and roll and run with this, you are free to pause the video right here and go do your homework. I'm going to go on and do the next two kind of on a little bit quicker scale, just for those of you that are a little nervous and not so sure. All right, so let's continue on. For those of you that are heading off, I hope you have a great day. All right, for those of you that are staying with me, let's go ahead and graph our data points. That's our first thing. I'm going to draw my axes right here on the edges. All right, we've got 2, 3, which is right there. We've got 4, 6, which is right there. We have 6, 1, which is right there. And we have 8, 4, which is right there. Let's do this one a little bigger. We've got our pink line and our orange line. You guys can use whatever color you want. You don't have to use any color. I just do that to make it show a little bit better for you guys. All right, orange. Here we go. Negative 1/2 plus 6. All right, so we go up 6. 1, 2, 3, 4, 5, 6. Negative, so we go down 1 to the right 2. Down 1 to the right 2. And we draw our straight line through it. There we go. Now let's switch to pink. Pink is negative x plus 8. So we go up to 8. And we're just going to go straight down 1 over 1, down 1 over 1. Like so. Okay, so there are our lines of best fit. Now we've got to calculate our squared residuals. Okay, doing the orange line first. To go from the line to the data point, we had to go down, so it's negative. We went down 2, so this is a negative 2 squared. Plus, for the next one, to get from the line to the point, we had to go up 2. So this is a positive 2 squared. We add it to the next one. To go from the line to the point, we went down 2. So this is a negative 2. And for our last point, to go from the line to the point, it's a positive. So this is 2 squared. So you're going to have 4 plus 4 plus 4 plus 4 equals 16. Great. Oh, I can't do that. I was trying to erase my little jumps here so that you can see it a little bit clearer. You don't have to erase them. I just do it for clarity for you guys. All right, let's do the pink line. Pink line. To get from the line to the data point, you had to go down, and you went down 1, 2, 3. So this is a negative 3 squared, plus the next one, we went up 2. So this is 2 squared. Then on the next one, we went down 1, negative 1 squared, plus on the final one, we went up 1, 2, 3, 4. So this is going to be 4 squared. So you're going to have 9 squared, 9, not 9 squared, plus 4, plus 1, plus 16 for a total of 30. Is that right? 13, 14. Yep, 30. So as you can see, the orange line has the lowest squared residual, so therefore it is your line of best fit. Okay, so what I realized is I made a mistake in thinking that I had a third example for you guys. I don't. I only had the first 2 examples. So at this point, my video is done. Go make an attempt at your homework. If you have any questions before or during your homework, jump back into my Zoom meeting. I'm there. I'm ready to answer any questions you have and help you get this figured out. All right. I hope you guys have a wonderful day. I love you all. I will see you on Wednesday.